We were the only class that had the regular time hour on Friday. So I just want to start over just explaining this problem as we get into the next group of weird stuff. Just so we remember what normal looked like. Normal was x squared minus 4x plus 1. We put it into our graphing calculator. It makes sense that this is an up-opening parabola, and we know that because we have an x squared in front, and the leading coefficient would be a 1. And it does dip below the x-axis. So they wanted to know, when is it greater than or equal to 0? And that was here, here, and directly at those two spots. So we used our graphing calculator, got ourselves a nice little table so we could get a reasonably accurate graph. And then we used the second trace 0 feature to get these 2 points. And some people, when they've started working on the review, I never push people to memorize. You know, I would rather that you go a little more in depth into the problem and understand what's going on. But they said, is there just an easy way to remember if it's greater than what I should be doing? You know, how I should use that? Well, that's hard to do because some parabolas open up and some parabolas open down. So if it's an up-opening parabola, it's always going to be an or for greater than or greater than or equal to. But for a down-opening parabola, that would be an and. So you really do have to get that little sketch in your head of what it looks like before you figure it out. And then ors have the union notation, and we write this in interval notation. So we wanted the answers that were above, and we needed to use that union notation to show where those were. Joey guessed at the candy, so I put a little piece of paper on your desk that has the numbers that you guessed between. So the 0 feature, it's there, we can use it. It's kind of a last ditch thing. We can't factor it, we can't figure it out any other way. They put the little graphing calculator icon there, and we need to be able to find it. So now we're going to look at what happens when things get hinky. Well, we know from past learning, even just talking about solving systems of lines. You like to solve system of lines and get one ordered pair for a solution. But we know that's not the only thing that can happen. Sometimes they're parallel lines, and so we don't get a solution. And sometimes you graph one line and the other one's right on top of it, and you have infinitely many solutions. So we're going to see every once in a while something weird is going to go on, and it needs to grab our attention. So with quadratics, there can be one solution, there can be no solutions, and there can be infinitely many solutions. And by one solution, we're really talking about kind of an interval notation. So showing that a quadratic inequality has no solution. Well, that would pique my curiosity, so I would start looking at that and say to myself, why would that have no solutions? Well, everything's positive here. Well, what if I put a negative in? Well, I'm going to have to square it, and that's going to be bigger than 2 times a negative. So no matter what, this is always going to come out positive, no matter what I put in there. Even if I put a 0 in there, 0, 0, 2, it's going to be positive. But for most people, you want that visual. You want to see what's going on. So let's get this in the graphing calculator, and let's put p at x squared plus 2x plus 2. That's with my Zoom box from another problem. Zoom 6. Oh, there it is. It doesn't have any real zeros. It's not going to touch the x-axis. The whole parabola is above the x-axis. Well, we'd have to show that, because if we're going to put down no solutions or all solutions, all real numbers, we want to know that that's actually accurate. So second table. And we'll just put some of those in there. Let's see if we go to -4. Yeah, that's a good number there. So let me write them down here on the main screen. And we can get those graphed. So we had -4, 10, -3, 5, -2, 2, -1, 1, 0, 2, and we'll go over to that one. 1, 5, and 2, 10. So this would be visual graphical evidence of the fact that this doesn't have any solutions once we get a graph. So the whole reason this has no solutions is because it never reaches the x-axis. So there's no way that the y value can be less than 0. So another question would be, how can we make one where we would have to put all real numbers? All we would have to do is flip this inequality. That's all we would have to do. This entire graph is above the x-axis. And that's what we see, and boy, I don't know if you can even see that. Oh, neon thing there. If we solve this for greater than 0, the whole thing is greater than 0. So we'd say, hey, all real numbers, which would be negative infinity to infinity, when we're using interval notation. So that's just how it happens. You know, like I said, this is one of those where you're working away and you go, wait a minute, something goofy's going on here. This one's goofy. What's wrong with this? And then you just have to think your way through it. And the visual definitely helps you get an idea for, is it no solutions? Is it all real numbers? And then beyond quadratics. Ooh, that sounds dramatic. If we can factor it, we should. A lot of times we're not going to be able to. If we can't factor, then we approximate with the graphing calculator. Last year, when we wanted to find all the real zeros of something, the first thing we did was we tried to factor, because those are nice. But in the end, we grabbed the graphing calculator and we found our zeros and we verified them synthetically to make sure that they work. That's a step we're not going to take in right now. We're not going to verify our zeros synthetically. But we are going to use the graphing calculator to help us figure out what exactly is going on when it has something that's not factorable, and that's what's taking place right here. So x cubed plus 2x squared minus 1, the first thing we do is try to factor it. Well, there's no greatest common monomial factor, and it has a cubed in front. Well, we can't break that down into two sets of parentheses. That's a no-go for us. So what we'll have to do is we'll have to graph it, and then think about where our solutions are going to be at. So let's plop it in. X cubed plus 2x squared minus 1. Now we know what it should look like. It's x cubed, and as a positive leading coefficient should be a nice S curve for us. Let's get some numbers. Second table. Start at -3, -10. And I'll write all these down. All these in here. -3, -10. -2, -1. -1, 0. 0, -1. 1, 2, and 2, 15. So we have a place to aim. We'll aim at that 215. So -3, -10, we're down there. -2, -1. -1, 0. 0, -1. 1, 2. And 215. Aim it up there somewhere. They wanted to know when that was greater than or equal to 0. Above the x-axis or below? Greater than or equal to 0, above or below? Above. Okay, so here's what we want to tell them. we want to tell them it's this little itty bitty piece right here, and it's that stuff right there that's above the x-axis. Should we include these zeros? Yep, got an equals bar. We need to know those. The good news is we know one of them. The table gave us one. This is -1, 0. But we need the two other ones. So we're going to go back to the graphing calculator and use our zero feature. Second trace, number 2. And I'm going to find the rightmost 0 first. So I think I'd like to do some zooming in to get the other one. So 0.618 for that rightmost one. But now, like I said, I'm going to do a zoom box. So zoom 1, and since the smartboard has not liked using the arrow buttons today, I'm going to cheat and come to the computer and hope for the best. There it goes. So upper left-hand corner of a box, enter, down, come on, ooh, a little too far down, and to the right. That should be a good little zoom there. So now I can see it clearly. And chances are we might have been able to get it off the main screen, but this way we're absolutely certain we'll get it. So second trace, number 2, and come on, Blinky. There it goes. Come on, push your button. Okay, I'll give it up. I'm going to go back to the computer. I sure wish that arrow button worked nicer. I guess I should look at it this way. I could come up with a new medical condition by the end of the year. Calculator finger. Like carpal tunnel came out when everybody was sitting at their desks all the time typing. Word processors. Calculator finger. -1.618. Okay, so 1.618, 0.618. Yeah, there it was. So now we just have to describe that with interval notation and say, okay, we want from here to here, and then we want that. So help me out. How do we do that? How do we describe all of that? Find you at your desk, and then I'll just call on one. I know what it is. You're afraid of your voice getting on their phone. Matt, you're looking done? No? You're not done? Josephine, you look done. No? Because remember, when we want that and piece, that piece where it's everything in between those two, that's actually really nice in interval notation. And we just use a bracket for that. It's this piece that's kind of the hanger-on, where we have to go out to the right forever. But we do want to include those endpoints because we did have an equals bar, so we have to include those endpoints. So weird stuff. The weird stuff would be no solution, all real numbers, and then stuff that we look at and say, gosh, I can't factor that. What am I supposed to do? Well, that's graphing calculator, and that leads us to rocket science, projectile motion. Oh. Projectile motion, the movement of an object that is propelled vertically up into the air, but then subject only to the force of gravity is an example of projectile motion. Physics students, we know that's a bunch of bunk because air resistance is there, if nothing else. But we want to start with the most basic form of projectile motion possible. So we're not throwing in air resistance or anything right now, just gravity. That's it. So projectile motion, suppose an object is launched vertically from a point S sub naught, that's what S sub 0 stands for here. So S sub naught feet above the ground, with an initial velocity of V sub naught feet per second. The vertical position S in feet of the object's t seconds after it is launched is, wow, that was a lot of blah, blah, blah. So here's what this formula says. It says the height of whatever it is you're putting up in the ground. I'm going to go right here. So let's say it's at 1,200 feet. You're going to put the 1,200 right there. Negative 16t squared. Well, the negative 16 comes from gravity. That's a part of the formula that's developed due to gravity. T squared is how long has it been up in the air? That's the time. V sub naught, initial velocity. When it was fired, how fast was it going? And there's that T for time again. And then this last one is, where did you fire it from? Was it on the ground? Was it on top of a building? Maybe it was on top of a table. And where did you fire it from? All of that affects this formula. So like it says, V sub 0 is V sub naught. And S sub 0 is pronounced S sub naught. And we're going to do a little rocket science. A little bit. Not a lot. A little bit. A projectile is launched straight up from ground level with initial velocity of 288 feet per second. I saw two pieces of important information for our formula. We started at ground level, and the initial velocity was 288. So it would be 0 equals negative 16t squared, because we don't know anything about time. They didn't tell us about time. Negative 16t squared plus V sub naught was 288t. Ground level. What do you use for a number to represent ground level? I like that number. Ground level is 0. Well, so far so good. Now we just need to see what they want. A says, when will the projectile's height above ground be 1,152 feet? Well, I don't know, but I'm going to put it right there. And hope that good stuff happens. And I realized, well, I don't need that plus 0 over there. And I hope this is factorable. I mean, maybe it won't be, but I hope it is. So I'm going to go ahead and subtract 1152 from both sides. For the sake of that, 2 for 288. My T is going to look like a plus. Better make it curved. That one kind of looks like a G. That's not too bad. Don't want to do pluses. Now, I don't know about you, but I'm really hoping all of these numbers are divisible by negative 16. So check on your calculators for me. Is 288 divided by 16 something nice? And is 1152 divided by 16 something nice? Both are a go? Cool. That should make our factoring a lot easier. 8. How many times for 288? Is it 18? 1130, 1152. 72 times? Okay, so we've got t squared minus 18t plus 72. Well, that's factorable. So here's what we have to find. Two numbers that multiply to 72 and add to negative 18. Not the first set, but minus 12 and 6. Yep, 72, most people go after 9 and 8, That's cool, because that means 6 seconds and 12 seconds. But I better go read the problem, because I want to know, did it say at least, or did it say, you know, at most, or something like that, or do they just want 6 and 12? And A said, when will the projectile's height above ground be? 1,150 feet. Cool. 6 seconds and 12 seconds. But B says, when will the projectile's height above the ground be at least 1,150 feet? All right, well, I better make a sketch then, because I think that's going to help you figure this out. Does this parabola open up or open down? Down. It's got a negative 16 in front. So I'm not making this necessarily accurate. All I'm doing is making a sketch and saying, going to look like that. And then somewhere here would be 1,152. Well, I know more than somewhere. I know this would be at 6 seconds. And this would be at 12 seconds. So, a couple of questions. First off, above or below? It said at least. Above, okay. And then, do we include the endpoints? Which means we need to answer the question, is 1,152 at least 1,152? It is, so we have to include those two endpoints. So in interval notation, what's that going to look like? Those brackets. Yeah. And now, you know, just like in physics, if you were answering this, you'd like to give a sentence that just kind of pulls it all together. And we would tell them between 6 and 12 seconds and including the 6 and the 12. So something like that, but we have a fancy word for it. It's called inclusive. So anywhere between 6 seconds and 12 seconds inclusive. Which means you are going to include the 6 and the 12. So those are included as part of the answer because it's at least and it worked. Now, there's their little sketch, but it's just a sketch. That's all we needed. You know, if you're going to do it on the grapher, that's great too. This test, we're not taking the graphic calculators away from you yet, so you can definitely use the visual of what you see to get the answers for you. So today's objective were first hinky things. No solutions, all real numbers. Stuff that we can't necessarily factor. And things that we may or may not have to use the graphing calculator for. And this one was really nice for our rocket science. So 43210 me on finding these zeros and these those are good numbers. Hey, raise your hand if you that formula for projectile motion from like physics or something. Yeah, I was going to say practically everybody in here, I'm sure, has seen that. We used it in algebra too, but it's been a while. And there is our fabulous assignment. It's the same one that was up there. So some of you stopped, I'm sure, and said, let's wait and get a little review here on this projectile motion stuff. And others just went ahead and gave it to me today anyway, which is good because that means you're feeling confident about your projectile motion. So now let me get you your little review sheets and we'll talk about